Good morning. Today we are going to study about the RVDT, that is Rotary Variable Differential Transformer. That is, the RVDT's full form is Rotary Variable Differential Transformer. The designing of RVDT is same just like LVDT. That is, LVDT we already studied in the previous section. Here the RVDT is an electromechanical transducer and it is also an example of passive transformer, and that means an AC source is given to our RVDT for its working, and it is used to measure the displacement. That is, RVDT translates the angular motion into electrical signal, and LVDT translate the linear motion into electrical signal. This is the main difference between RVDT and LVDT. And it has a transformer, that is, it has both primary and secondary winding, and output is called differential transformer because the output is the difference of the voltage present in the two secondary coil. And the main difference between RVDT and LVDT are the core. Where in LVDT the core is a linear straight one, but in RVDT it is a ferromagnetic core and it is connected with the shaft. The shaft can move in an angular motion. That is, the RVDT stands for Rotary Variable Differential Transformer. It is one kind of electromechanical transducer. It is used to give the linear output which is proportional to the input of angular displacement. The main function of RVDT is to detect the angular displacement and convert into electrical signal. And both the RVDT and LVDT is working in similar, but LVDT employs a flexible iron core for displacement measurement, whereas RVDT employs a cam type core. That is, this is the cam type core, and this core will be turned among two windings and of the transformer using the shaft. That is, here we have the core and it is connected to a shaft. The shaft is moved in just like angular displacement. Here we have primary winding and two secondary winding. Each secondary winding has same number of turns, and the primary winding is excited by AC source, so it is called as passive transducer. And when the AC source is excited, at that time induced voltage is across in the secondary windings due to mutual inductance, and the induced EMF produced across S1 is ES1 and induced EMF produced across S2 is CS2, and total output voltage E0 is equal to ES1 minus ES2. That is, the construction of RVDT is, it has mainly two windings, that is primary and secondary windings. The secondary winding has equal number of windings, and the secondary coil is located both sides of the primary winding, and the cam form the magnetic core which is made with the soft iron and which is connected to the shaft. Thus this core can be twisted among the windings. The construction of both RVDT and LVDT are similar, but the main difference is the shape of the core of the transformer. That is, core will turn between the two windings of the transformer due to the help of shaft. And the typical RVDTs are a linear over plus 40 or minus 40 degree, and the sensitivity is about 2 millivolt to 3 millivolt per degree of rotation. And based on the movement of the shaft of the transformer, there are three conditions that will be produced, such as when the core is at null position, and when the core rotated clockwise direction, and when the core rotated anti-clockwise direction. Now when the core is at null position, this is the first condition. When the shaft is placed at the null position, then the EMF produced on the secondary windings are similar and also reverse in phase. Thus the differential output potential will be 0. That is, in this condition, our induced voltage E1 is equal to E2 and output voltage is equal to E0 is equal to E1 minus E2. That is 0. And when the core rotates its clockwise direction, and the shaft rotates the direction of the clockwise, and more section of the core will be enter across the primary winding. Therefore, the induced EMF across the primary winding is higher than that of secondary winding. Hence, the differential output voltage is a positive one. Here, the E1 is greater than E2. So, the output voltage is a positive value. That is E0 is equal to E1 minus E2. Now, coming to the third condition, when the core rotated the anti-clockwise direction. When the shaft rotates the direction of the anti-clockwise, the more section of the core will be entered into across secondary winding. Thus, the induced EMF across the secondary coil is higher than that of primary coil. Hence, the differential output potential is negative. That means there is a 180-degree phase shift. 180-degree phase shift, and the condition will be E1 greater than E2, where E0 is equal to E1 minus E2, that is a negative condition. And this is the working of RVDT. That is, it has mainly three conditions. When the RVDT is at the null position, when it is in the clockwise direction, and when it is in the anti-clockwise direction. At the time of null position, the EMF produced both is equal to E1 is equal to E2, and at the time output voltage is 0. When the core rotated the clockwise direction, the more section of the core will be entered into a primary winding. So E1 is greater than E2 and it is a positive value. And when the clock rotated anti-clockwise direction, at that time E1 is less than E2 and it is a negative value. Now coming to the RVDT advantages and disadvantages. The advantages are the consistency of RVDT is high and exactness of RVDT is high. The lifespan is long and the performance is repeatable. The construction is compact and strong. That is the durability and low cost. It is a low cost one and easy to handle in electronic equipments. The resolution is infinite and linearity is excellent. A wide range of dimension range. These are the main advantages of RVDT. And coming to the disadvantage, the exact among the measuring exterior as well as the nozzle is not possible for all time. And the output of the RVDT is linear about plus 40 or minus 40 degree. So it restricts the usability. And the applications of RVDT are fuel valves as well as hydraulic and modern machine tools, controls the cockpit, controls the fuel, brake with cable system, engine split air system, and in robotics, aircraft and avionics, process of control, industry, weapon and torpedo system, engine fuel control, nose wheel steering system, fly-by-wire system, etc. And these are the main working of RVDT and application, also advantages and disadvantages of RVDT. Thank you.